Around 2 million years ago, Earth was a very different place. Our early human ancestors lived alongside saber-toothed tigers, mastodons, and giant rodents. Depending on where they were, it could have been quite cold too. Earth had plunged into a deep freeze with numerous ice ages coming and going until about 12,000 years ago. Scientists theorize that these ice ages occurred due to a variety of factors, including the planet's tilt and rotation, shifting plate tectonics, volcanic eruptions, and carbon dioxide levels in the atmosphere. But what if these drastic changes were also influenced by the Sun's position in the galaxy? Our entire solar system is enveloped by a protective plasma shield known as the heliosphere, which is created by the solar wind, a continuous flow of charged particles from the Sun. This heliosphere extends well beyond Pluto, surrounding the planets like a giant bubble, as NASA describes it. The heliosphere shields us from DNA-altering radiation and galactic cosmic rays, which scientists believe is part of why life was able to flourish on Earth, according to a recent paper. A cold cloud compressed the heliosphere so much that it briefly placed Earth and other planets outside its protective influence. Their models have reshaped our scientific understanding of the heliosphere and how the solar wind, pushing against the interstellar medium, the space between stars and beyond the heliosphere, structures this bubble. Their theory suggests the heliosphere is shaped like a puffy croissant, a concept that has stirred the space physics community. This research sheds new light on how the heliosphere's shape and the Sun's movement through space could influence Earth's atmospheric chemistry. Normally, the heliosphere filters out many radioactive particles, but without its protection, these particles could easily reach Earth. Geological evidence aligns with this theory, showing increased levels of isotopes like 60 Fe and 60 and for Pu plutonium-244 in the ocean, on the Moon, and in Antarctic snow and ice cores around the same time, correlating with cooling periods in temperature records. It's exciting to discover that passing through dense clouds millions of years ago may have exposed Earth to a much greater flow of cosmic rays and hydrogen atoms. Our findings open a new window on the relationship between the evolution of life on Earth and our cosmic neighborhood. It's not possible to know exactly how these cold clouds impacted Earth, but it seems they might have triggered an ice age. Opher points out that the Sun has likely encountered several such cold clouds over billions of years since it was born in the interstellar medium. We might encounter more in about 1 million years. Opher and her colleagues are now trying to trace the Sun's position 7 million years ago, and even further back, using data from the European Space Agency's Gaia mission. This mission has created the largest 3D map of the galaxy, offering unprecedented insight into the motion of stars. This cloud was indeed in our past, and if we pass through such a massive thing, we get exposed to the interstellar medium, says Opher. The effects of intersecting with so much hydrogen and radioactive material are unclear. So Opher and her team at Boston University's Shield Solar Wind with Hydrogen Ion Exchange and Large-Scale Dynamics Drive Science Center are now investigating the potential impacts on Earth, including radiation, atmosphere, and climate. This is just the beginning, Opher says. She hopes this paper will open doors to more research on how external forces in the distant past influenced our solar system and shaped life on our planet.